Hello everyone, welcome to my channel Middleware Technologies. Today we'll be looking at how we can do RPM packaging and software distribution using the package management tools that are provided on Linux operating system. Okay, so as RPM is called RPM package management tool, it is used to manage and update the software on the Linux system. Okay, so we can install, upgrade and remove packages from the Linux operating system, and we can also query the RPM database which stores information about the RPM packages that are installed on our system. Okay, so this RPM packaging tool is used for that purpose, and it also stores the metadata information about the RPM packages that are installed on our system. So this is very much used on the Red Hat based systems like Red Hat, Fedora and CentOS, to name a few. Okay, so here in this video like we will see how we can prepare a source code and try to build or package it into an RPM package using the tools that are provided by the RPM package management tool, and we will try to install that RPM package onto the Linux system and see whether our source code with which we are trying to achieve a task is being done or not. Okay, so I'm going to follow this guide to show you like how we can do the source code packaging using the RPM package management tool. Okay, so let us get started now then. Okay, so this is as a first step, like we need to have the source code ready so that we can prepare the package. Okay, so source code is basically human readable instructions that we write in a text text file which is then given to the computer for executing the program. Okay, but there is a lot of things that happens in between that we will try to see in this video. Okay, so as I said, like we as a first step we need to have the source code available which we can package. Okay, so let me go into my shell. So I'm already there in my RPM packaging tool, RPM packaging folder, and here like I have created my hello world Python program. Okay, so this is the shebang line which basically identifies the Python interpreter, and this is a statement which prints the hello Python when we execute this Python program. Okay, so this is a simple very basic Python program which we will try to do package into an RPM and try to install in our system. Okay, so let me clear my screen and go into my instructions user guide. So as a first step, like we have our source code ready. So as a second step, we need to build the Python source code. Okay, so what exactly it means is we need to like basically convert that human readable instructions into something that the computer can understand. Okay, but coming to this point, like there are various like different types of programming languages that are available which work differently, like which try to execute the programs in a different manner. Okay, so if you take C and C++ language, those languages, like the software is are called the compiled languages. Okay, so basically like we take the source code, we compile it into a native instructions for the computer. Okay, so it basically is specific to the architecture, platform architecture, wherein we are like actually compiling the software. Okay, coming to the other languages, like let's say if we are taking the bash language, so for this is like raw interpreted languages wherein the source code is not built but it is executed directly. So let's say if you go into your shell and try to run a date command. Okay, so if you go and to your shell and run a date command, so it basically executes and prints the date. So it's basically like we are not compiling and converting that instruction into a native language. So this is called raw interpreted language, the bash language. And the third one is the Python language, wherein the software is byte compiled. Okay, so it is actually when we execute the Python program, it is compiled and then interpreted by the virtual machine that is provided by the Python software. Okay, so these are the three types of languages that we come across. And yeah, so here like we are using the Python source code, and we will see how we can compile the Python source code using this step. Okay, so let me paste this. So we are compiling our hello world .py file with the Python module, with the compile all options. Okay, so it basically creates our compiled file of our source code. So let me execute it. So it is compiling, it has compiled our source code, and if you see, like it has created this cache file. And if you go and look at the tree structure, you will see that a pyc file has got created within the cache folder. So this is basically the compiled file of the Python source code. Okay, so this is how basically we compile the programming language, like Python programming language source code into a Python compiled file. Okay, so let us go further and see what we can do in our next step. Okay, and one more thing I just wanted to mention. So this like RPM packaging that I'm showing you for the Python program, so this is very very basic one, but the actual Python software applications are built in a different manner. So if you go into the software packaging and distribution section of the Python documentation, like you will get to see like how actually the Python software is packaged and distributed. Okay, but this tutorial is basically to get you well versed with the RPM packaging methodology, so that you can understand and apply it to other languages also. Okay, so let us go further into our next step, the step number 3, wherein we need to package the source code into a tarball. Okay, so how basically the source code that is developed by the developers or anybody who is contributing to the source code, like how they package their source code. Okay, so we can package our source code using a compressed tar file. Okay, so for that we need to take the source code, and we need to also add the license file into that source code, so that whenever we are distributing that software or the source code, we are sure that we have nobody tampering or misusing the source code. But as we are developing this as we are demonstrating this this packaging as a demo, like I'm using the open source GPL license. Okay, so let us see like how we can do the packaging of the source code. Okay, so let us first create a folder with a version number. So let me clear my screen. So here I'm creating a folder in the current directory wherein my source code is available with 011 as the version number. Okay, so once that is done, we will move everything in the current directory to the version folder. Okay, okay, so let me clear my screen. So I just need to move the hello world.py and the py cache to hello world folder with the version number. Okay, so now if you go, do ls-ltr on that folder, we will have the source code with the compiled file available in that version folder for packaging. Okay, so as I said, like we need to put the license file also as a part of this package. Okay, so we will create this license file. Let me save this file and I'll move this license file also to the hello world folder which we want to package. Okay, now what we'll do is we will compress this folder with the following step. Okay, so this is going to create a compressed tar file for us and keep it in this folder. Okay, so as you can see, the tar.gz file is created. So our source code is packaged. So now this source code package is ready to be distributed. Okay, so we can distribute this package to anybody who wants to do the RPM packaging for this one. Okay, so in the next step, like now we will see like how we can do the packaging. For that we need to have the RPM packaging tools installed. Okay, so we will need to install all these tools. So basically I have all these tools already installed. Okay, so RPM dev tools is the main package that provides all the packaging tools required for the RPM packaging, and RPM lint is basically for scanning or validating your RPM packages once they are ready to identify if there are any issues with the RPM packages. Okay, and git all is basically a weak dependency I am installing for source code management. Okay, so let us go into our guide and see. Once the RPM dev tools is installed, like you can check the list of utilities that are available that are provided by this tool using the following step, wherein we are basically querying to provide the list of files that are available in RPM dev tool and under the bin directory. Okay, so these are all the dev RPM dev tools that are provided by the RPM package. This is the RPM dev tools package. Okay, so let us go further into our next step. So as a step 5, like what we need to do is we need to set up the RPM packaging workspace. Okay, so for that so basically we need to run this RPM dev setup tree. Okay, So let us try to run this one. Okay, so what it does is basically if you do ls-ltr home directory, okay, so it is going to create this rpm build folder. Okay, so let me do a tree view of so ls-ltr home directory and rpm build. Okay, so it will contain all this folder structure, or basically it is a template structure that gets created with which we can do the rpm build and packaging. Okay, so as you can see, it contains source folder wherein our source files, the compressed files are kept, and this is srpm, that is the source rpm, wherein the source rpm packages are kept, and the third one is rpm package, rpm folder, wherein the binary rpm packages are kept, and the specs folder is where the build spec file is kept, which provides with the information, metadata information and the instructions for building and packaging the source code. Okay, so this is how the package structure gets created when we run this rpm dev setup tree tool. Okay, so we'll go to the next step and see what further we can do to do the rpm packaging. Okay, so as a step 6, we need to copy the compressed source file package into the rpm build workspace. Okay, so what we are doing is the compressed file that we created, right, the compressed file that we created, we are going to copy it into the rpm build source folder, as I said earlier. So source folder contains the source files related to our application. Okay, so we have copied that. Okay, now coming to the next step, this is the important step wherein we need to create the build spec file for our rpm packaging. So as I mentioned before, like there are two types of rpm that we can build or package, that is source rpm and the binary rpm. Okay, the source rpm contains the source code and the spec file which describes how to build the source code, and the binary package, it contains the binary built from the source code and other patches that we apply to the source code. Okay, so here in this step we will create the spec file. So for that we need to go into the specs folder in the rpm builds folder. Okay, here I have the spec file already available for hello world. Let me show you. So if you go into the spec file, it is basically divided into two sections. The one section is called the preamble, which contains metadata, and the other section is called the body part, which is the main part which contains the instructions for the build and the execution of the package. Okay, so if you take a look at this, okay, so this section, like what I have highlighted right now, so this comes under the preamble section, wherein we provide the metadata like name, version, the release, and if you see this in the flower brackets question distribution, so it is basically a macro that gets replaced by the actual value. Okay, and this is a summary and the license which we are using, and the URL and the source code, like you can just ignore it for now, because I'm not actually copying or distributing this package using a repository. So for now, like, you can just ignore, and you can provide the host name of your server wherein you are compiling this. You are basically building the package. Okay, and this section basically tells like what is required for the build. Okay, so build requires shows like we need Python 3 for building the package, and requires also like we need Python 3 and requires uh, this is bash for shell execution, and Python 3 for the interpreted execution of the Python package. Okay, and build arch specified no architecture, because this is not architecture specific. We are compiling it into a bytecode, and then it is being interpreted by the Python interpreter on a Python virtual machine. Okay, so this is the preamble section, and then coming to the other part. So this is the main body part, wherein we have the build instruction, the install instruction, wherein we are copying the binary basically into the user lib directory. Okay, and once that package is available, okay, we are using a shell script to call our Python script, the Python source package using the Python 3 interpreter. Okay, and we are giving the 755 execution for that package that we are going to execute. Okay, so this is how like you can create your build spec file, and we have in the file section you can see we have included the license, the directory user lib, where the package is going to be installed, and the change log basically shows like who changed and at what time it was changed, basically providing the information for the package. Okay, so this is a very basic spec file that I have, and once our spec file is ready, we can build the source RPM using the RPM build utility. Okay, so let me run this command. So RPM build source, this is the option with the spec file provided. Okay, so this has created the source RPM in the following folder location. So if you do ls-ltr, we have that package available. So if you do RPM minus qf to list what is available in the package. Okay, not qf, it is ql. Okay, so you can see the source code package and the spec file is included in the source RPM. So basically it contains the instructions in the spec file. With this it is going to build the source code which is available in the compressed tar file. Now coming to our next step, we are going to build the binary RPM package. Okay, so for that we are going to use the RPM build binary. This is the step we need to execute. BS was for build source and B is for build binary. Okay, so as you can see the build binary step has been completed and it has created the package in the following location. Okay, so as you can see it created the folder in the RPMs folder. It created the binary RPM in the RPMs folder, and in the top if you see I just wanted to show you, like the source RPM was built and was kept in the sRPMs folder, you can see. Okay, so this is how the folder structure, the workspace gets utilized by the RPM build tools. Okay, so now coming to the RPM files, so we can list the RPM binary RPM with the following command, which shows all the files that are available under this binary package. So once we install this package, it is going to install the files at the following location as shown below. Okay, so so we have built our binary RPM, and now we can use the RPM lint tool it is basically to validate the spec file or the build RPMs or the binary RPMs that we have just created. Okay, so let me show you one. So I'll show you for all of them, so it should not take much time. So RPM lint hello world spec, it will show the information, the validation results of the spec file. So as you can see, it has mix of spaces and tabs, so it highlighted that one. And if you do the RPM lint for the source RPM, so it will provide the information about the source RPM, and the same thing we can do for the binary RPM. Okay, so this is how we can use the RPM lint tool to validate the RPM packages and the spec files that we have created. Okay, so you can see there is an error, but basically this highlights that it is a warning that highlights that the py file has no execute permission. Okay, the RPM tool, basically it is expecting the file to be executable because the file contains the shebang line. Okay, so that is the warning. Actually you can ignore it. For the purpose of this example, you can leave this file without execute permission, ignore this error, because we are actually, if you have seen the build spec, let me open this, we are executing the package, the py file, using a bash shell. Like basically we are wrapping the Python step into a bash script, for which we are providing the execute permissions. Okay, so you can ignore that warning. And so let us go further into our next step, the step number 11, logging RPM activity. So basically, so any to troubleshoot any RPM issue, like RPM installation or update issues, we can install the following the plugin package, which will help us to identify any issues with the RPM package installation or any other issues that we see with the RPM package. Okay, so that package we can install it. Okay, once that is done, like we can go with the final step, that is installing the binary RPM package that we have created. Okay, so here, so I'm going to install the binary RPM package that was created in the RPMs folder. Okay, so this one I'm going to install, but as you can see, it shows the package is already installed, but let me uninstall that one. Okay, sudo dlf remove Okay, so now let us try to reinstall that package. Okay, now we can say yes, so it has installed the package. Okay, so now if you do use so how we can verify the package? Okay, so we can do query information for hello world package that is currently installed, and you can see all the metadata that we have provided in the build spec file is available over here. The one that I have said, the first part of the build spec file. Okay, so this is how you can look at the information of the package, and you can list the files using rpm-ql. So this is how the package gets installed on your file system. Okay, now if you run this, it should show you the hello Python which we have written in our source code. So this is how basically we are going to do the RPM source code build and packaging using the RPM package management tools. Okay, and there is one more thing I wanted to mention. So basically the RPM tools like they follow this this file hierarchy standards. Okay, so basically what it means is files installed from RPM packages are placed according to the FHS standards. So what it means, like bin directory will contain the binary, lib directory will contain the library files, the etc directory will contain the configuration files. So this is called the file system hierarchy, which is followed in the Linux file systems. So it will be this is what we are following with the RPM packages that we are trying to build over here. Okay, so this is how we can build the source code and package it into our RPM and install it on our Linux system, so that we can use it as a native like tool to run it directly, rather than going into rather than going into a specific folder and trying to run our Python scripts or any other language source files that we want to execute. Okay, so I hope you enjoyed watching this video. Thank you all. Thanks for watching this video, and you guys have a great day.